that was nice. Yeah, I'm Polish, I'm from Poland, but on the schedule, the presentation was supposed to be in English, which I'm very comfortable with, unless there's nobody who doesn't speak Polish in here. Who doesn't speak Polish? Oh, okay, hi Thomas. Okay, so we'll do it in English, it's no problem. I always ask this question because a few times I managed to sneak in and the presentation in Polish, which usually ends up with a few more funny jokes. Okay. Initially, that was supposed to be 6 tips for your JavaEE projects, be less depressing, but after the last Java one, I have to cut off one of the tips. So we have 5 tips. So why this talk? Does JavaEE, I still see it here. Houston, we have a problem? Okay, now it's here. Does JavaEE have to be so depressing? You probably came over to this talk because at least some of you are in some JavaEE projects, and it is not the best possible technology to probably work with. So I'll briefly talk why I had this idea to talk about JavaEE in 2016. And also, like 5 tips. Those 5 tips how to make it better. My name is Jakub. I came over from Gdańsk, from Poland. You can catch me out on Twitter or through email. I do various different things, and usually hang around. So I'm here for next 2 days, so you can catch up with me if you want. So why this talk? Yeah, we've considered to build, to use Java. We've chosen JavaEE to build our startup. No one has ever said that. It's usually that we have JavaEE or we work with JavaEE because this is the way we do things. JavaEE was present in the project a long time ago, before we came into the project, to the company. It will be probably there for the next few years, and there is not much we can do about it. Come on. I can see it here. Do I have to kick it? No, jest, pojawia się i znika. Okay. Just shout when, because I see the slide in here, and I know not always look here, so if it goes black, just shoot and I'll kick it or something. So there's no presentation without problems, never ever, so that's kind of. Yeah, we have JavaEE on our project because it has always been there, and it has always been a way for this particular, for example, company to do things. People tend to hate it for some reasons, usually because they are kind of slapped with the technology over the face. But it doesn't need to be that bad. Usually we get slapped by things that are internal to the company, like company standards. I think we all had that. I call it cargo cult. For example, you have a project, which is a fully enterprise project running application server that has like 4 modules. One is for WSDL files, for web services, some business services, some entities, and web version where the actual physical representation of the web service is present and the client and so on and so forth. The problem, for example, with this particular example is that the project actually, the project actually had like 20 class files and 4,000 lines of code. So there was no sense in splitting it into multiple modules, and also there was no sense in doing it because it was all maintained by a single person. However, in this particular company, you had to preserve the structure. Otherwise, the operations people will never ever let it on the production. That was the standard. Also, when you or when I encountered some JavaEE projects, we tend to see certain strange things like this, that people started to do their own threading and their own weird SOAP connections. And then when they consumed some SOAP data, it started to look like this, that they parsed strings and were looking for some faulty messages. It is not because JavaEE is bad, it is just some programmers are bad and didn't understand the technology. And this is what we are facing when we get some, for example, legacy projects into our company, or we have to work on something. Then one of the first idea many programmers have is that we can rewrite it better, we can do it better, because new is always better, damn it. Because, yeah, new is always better. The thing is, what do engineers tend to do when the technology they don't know, obviously, doesn't work for them? Yep, they change the technology. So the idea is that JavaEE doesn't work for us, so let's build it in Spring. That must be better. So now, after this decision, many teams have two problems, because they have Spring that they don't know either, and then they have a new application built in it. I think I've seen it multiple times. I don't think it's a technical problem. I think it's a people's problem, like management problem. People tend to make decisions on some, based on weird things. So it can end up with a very weird real-life stack, where you have a company that is having a latest cutting-edge WebLogic server that has pretty much JavaEE 7 compliancy, with JPAs, WebSockets, new JAX-RS, and so on and so forth. And the team builds an application based on Spring 3 on the top of it. Because, yeah, somebody chose that. I have an image that pretty much shows what we are having here. It looks like this. And this is why many people feel that JavaEE is bad and the whole idea about JavaEE is bad. It's usually because we have lots of very bad code, badly written applications that have to be maintained because they are in an environment that are not very flexible for change, like banks, like insurance companies, and they have this JavaEE, they have it for the past 10 years, and they will probably have it for the next 10. So yeah, this is something we end up very often with. So, yeah, can we do it better? Is there a way for us to make it better? No, damn it. Okay. We'll have a small technical switch with the cables. Na poprzedniej prezentacji też tak było? Dzięki. Yeah, new is always better. Okay, we'll see. What can be those five points? What I will wrap around, and the whole presentation now will be more technical and very more precise in examples, is I think I've divided it into 5 discrete elements that we can look into and think of to make our JavaEE applications less depressing. And those things are based on multiple projects I've been involved to, both those I've been working for a long time, as well as some shorter consultancy gigs where I try to help other teams getting around their JavaEE thing. So, first of all, we have to know our stack. JavaEE doesn't have to be that old, that bloated. Many things change, and I see that many engineers doesn't even know what happens in the latest and greatest JavaEE thing. Then we are very much inclined towards the whole idea of the standard. The standard is the thing, but it won't save us, and I will show why and what we can do to pretty much accept the thing that we are not working in a very standardized way. We are still very vendor dependent. And then we have to limit the amount of the boilerplate in our code. We can do it with JavaEE as well as we can do it in Spring. And then we can go beyond the standard, because yes, the standard edition, the JavaEE prescribes certain libraries as the standard, as the way to do things, but yeah, this is not a golden hammer. And we can change it, and there are ways to do it, and I will show you how. And then we don't have to be limited to JSF or Servlet to the single server-side MVC. We can do it differently, we can do it better in a more modern way. So I'll walk through those tips and show you how we can make it better. So now you're stuck. For example, this is very common misconception now about JavaEE, that as the enterprise application, the enterprise being under no circumstances can fiddle anything with the threads on the server application. This is still valid, but it doesn't mean that we cannot do multi-threading operations in our JavaEE applications. We cannot do it through running our own threads, because that might kill the server if, for example, we'd be very eager on new threads, but we can do it differently. And this difference is like from JavaEE 5 or 6, which is about 8 years old now, or 6 years old. So we can have, we do have an asynchronous annotation that pretty much allows us a block of code to run in an asynchronous way. We don't need threading. Or we have a managed executor service, so we can build our own threads and run it through the executor service, like in Java Standard Edition. The thing is that this very restrictive comment about threading and about the multi-threaded operations was because we could have killed the server if we just had too many threads, and we could have killed, if the threads were run independently of the server, that's something application server has no control of, and he cannot manage that. And if he is very eager on resources, he doesn't know whether he can kill this thread or he cannot, because he doesn't know it. So the whole idea about putting it into the JavaEE ecosystem is to allow the application server to manage that. And we can do it. It's kind of obvious since for past few years. But these are not only things that we can do better on JavaEE stack. We have this whole idea of dependency injection and making it in more formal and better, and in a way we should deal with dependency injection, and we can then even inject some events and do some application events within our application, like we can do it in application context and Spring application. This all looks okay, kind of. This is something that is now very heavily lifted by people who are talking about, building your JavaEE application like more reactive, because this asynchronicity, this independent notification through events, this is something that people try to bake into JavaEE application to make it more resilient. Yeah, that's a way to go. It's kind of okay, but it's still not exactly what we expect from with having some experience from Spring. That's not what we are expecting, because we are still made to use very single, the single database and not engine, database framework like the JPA, but databases and ways to access the database is like opinions. Everybody has different, and we would like to use very lightweight database like persistence management, like JDBC template from Spring, or something like Spring Data, or we would like to integrate with whatever framework, web framework we are having, like in Spring. And yes, we can do it in JavaEE as well. So, before we get to that, one more remark. In many teams, I've seen that they start with something like this, that they are dependent only on the spec, only on the JavaEE specification, and that's something that they declare in their Maven dependency. However, very quickly they get to a point that they start to add another libraries that are very vendor dependent. And in fact, they have an application that is in JavaEE, and they think it is very standard and standardized, but never ever they try to run it on the different application server. And that's Probably because it will never ever run on a different application server. Because with Spring, we have a single vendor, single container. It wasn't as standardized, but all the changes and differences were manageable by either Spring or by us. And we could have done migration from one version of Spring to another in a acceptable time and manner. In JavaEE, we had multiple vendors, and each element of the spec was a subject to a certain interpretation. So it was a theory that we can run our enterprise application between the servers. In theory, it worked as long as our application was a hello world application. That could have probably worked. But as we get to a more like real life situations, it hardly ever does that. So to give you an example, there is no really as an injection standard in JavaEE per se. For example, if we imagine that we have a very simple service saying just hello, and we have two different implementation of the server, like my service and my other service, and both are stateless EJBs. So something obvious in the JavaEE world. And then we can try to inject it into our singleton bin with an EJB application. This is something we are doing on a daily basis in our apps. Does it gonna work? We have two bins, and we would like to inject through the interface. The answer is, and that is very good for consultants, it depends. Because it will work on some servers, it won't work on others. It will not work on JBoss application server. It will not work on Whitefly, for example. It will throw an exception that it cannot figure out which bin you would like to inject. On the other hand, if you go to the Apache sandbox and take Apache Tommy and Apache OpenEJB, yeah, it will just inject whichever. Probably the last in the class, but that's not guaranteed. So you have these differences with the interpretation of the spec itself between the servers, and that was very problematic. That's why pretty recently there was an idea about standardizing the dependency injection within JavaEE world with, for example, inject annotation, and that's very, very precisely written. It will blow up and throw an exception on us. However, even in the CDI world, so a standardized way to inject dependencies, there are differences between implementation, and we cannot do much about it. For example, there is a Weld and Open Web Beans, which are both implementation of the same spec, and you have to configure it differently because it behaves differently, and this is pretty much in yet another project's documentation. So yes, you have the standard, but still everybody is treating it differently. So maybe we should just accept it that, yeah, it's not a standard per se, and it's more like a guidance, and use a very exact dependency to our application server, because after all, our application server is a framework. Our framework is something that we are building our applications upon. And then if we see, for example, application server coming from a JBoss world or from WebLogic, we can see that even though it is not fully JEE 7 compliant, for example, it might be using the latest Hibernate or the latest Eclipse link, which gives us a lot of goodies, from example, from JPA 2.1. And then if we accepted that, yes, we are working against this particular server, certain things just gets better and easier. We don't have to work around the spec anymore because we just accepted that, yeah, the spec is just a guidance. And that allows us to move a little bit forward, because if we do it, we can limit a certain amount of the boilerplate. We can limit it in the things that we don't need to work around, certain problems with this spec. But we also can introduce some third-party libraries that gives us an idea how to make certain repeatable operations better. I don't know if you came across the project called Apache Delta Spike. Apache Delta Spike is a project. It's a set of CDI extensions, so context dependency injectable injectable extensions that you can add to your application, and it will just work from the CDI. It works on the number of CDI implementations and on a number of application servers. And it supports certain things, it adds certain things that are kind of missing in JavaEE, and it also allows you to take certain JavaEE things outside of the application server. But I would not talk about the delta spike per se, because it's it's a broad subject for another talk. I will talk about a very small part of this project called delta spike data. There is a sub-project called Delta Spike Data, which is pretty much like Spring Data, but without Spring. It allows you to reduce the boilerplate of JPA to the bare minimum, and it gives you lots of kind of CRUD-like methods, like in Spring Data, so save, find all, and find by, but you can extend it with your kind of repository methods. So it works pretty much like this. The example on the top is the delta spike. The example on the bottom is exactly the same code, but written in a Spring Data way. So as you can see, it's very similar. As you can see, you now can do certain repeatable operations in a very concise manner. So if you would like to query a person by its social security number, you can put a query in an annotation. Yeah, we have annotations there. And then it will auto-magically, pretty much, bind it with a JPA query and push forward to your engine. In exactly the same way, the Spring Data theme it does it. The problem I see here, because it says great, it gives you a very good productivity boost. The problem I see here is I never ever totally trust the generated code, because it's easy to start with such entity repository. You know, you don't have multiple layers, you don't have to type many things, build new classes, you just have it. You declare a simple query and it just works. But then you get to the more complex examples, and you start to see that it's not about JP, it's not about the delta spike data, it's not about Spring Data. The whole concept of JPA is, it's not working in our case. Usually, and that's something that Gavin King put, the author of Hibernate, that there is a certain particular use case behind JPA, behind Hibernate, and it's not a golden hammer for everything. It's not a golden tool for every database query. So you have to pick your tools, and you have to know which files you're going to find. So if there are some more complex queries, and we do not want to run them through a JPA, are there any others way to do it? Yes, there are, but before we get there, I'll just briefly tell you why this magic with delta spike happens on the JavaEE world. As a part of the CDI, introduced in JavaEE 6, so a few years ago, there's a concept of producers methods, of producer annotations, which allows you to generate an object that can be later on injected. If you've been working with JBoss theme like many years ago, they had the concept of outjection. So I can outject a bean out to the context. So this is pretty much how it works. You can build your own class and annotate the method as a producer method, and that it will be run by our application server, so that later on within the project we can just inject our coder bean with the producer method. We can do it with our own beans, but we can do it, for example, with things like entity manager. We don't have to inject entity manager in our beans through the persistence context annotation. We can build our own producer methods that will produce entity manager, and then we can inject it with our own inject annotation. That's perfectly legal in JavaEE world. And that leads us to yet another tip about JavaEE. We can go beyond the standard, and we don't have to use only JPA. There are many different database operations libraries. There are many, maybe better, for sure better in certain contexts, but there are different libraries that we can use with different things. So If we have, for example, a query like this, it's not very complicated. I've seen more complicated queries, but it's a little bit convoluted. It has some grouping and some concatenations, and it's a little bit SQL engine dependent. So that's not very suitable for JPA. What we will usually end up with, we will end up with native query annotation and just go straight to the database, bypassing the whole object relational mapping of the JPA. Yes, this is some idea, but if we are going to do like this, why do we need the whole bloated framework to just do a simple native call to the database? Can we do it differently? Yes, we can. We have multiple different libraries doing a very precise database operations, like, for example, JDBI. JDBI is very lightweight, very, very simple application. Coming from the idea is coming from Perl, where they have where they have DBI, so that we can pretty much run the code natively. So what we will be doing is we can inject the database resource, the JDBC low level, and then we can create any other bean, any other class like the DBI in here, and produce it as a CDI component and put it back to the context. So that later on in the project, we will be able to define a data access layer, an interface, with a query defined and the mapper defined, and we can inject this data access object to our code as any other bean within our application. And then we can bypass the whole JPA thing and get our native query natively directly to our application. Because JPA promises you that you will be able to migrate your database from one engine to, well, your application from one database engine to another. Yes, we usually do it in our companies when we are stuck to Oracle 12, and there is no other ways to run like half of our code without Oracle. So no one ever does it. I, in like past 10 years of IT career, had a valid requirement to switch the database engine once. So that's not a very popular use case. So if you are about to put a JPA native query in your code, you can totally legally do that because the effect will be pretty much the same. And this is much less bloated and much more, giving you much more control over the actual query and the actual connection with the database itself. However, this is not the only one, and this is not the only library that you can use for that. This is very kind of low level. You just throw in a SQL in a string, which is not very elegant, but it just works. But you can do something differently. There is yet another application in the ecosystem called Juk. Juk is a domain-specific language that is fully typed and allows us to build a SQL query within our Java code. You can create your Juk DSL and object it to the application context and then use it in very easy way, injecting it to your other beans. And if you would like to use Juk, then the simple SQL query on the top will look pretty much as the one on the bottom. It is fluent, it is Java code, but it looks like SQL, and it pretty much accepts that what we are doing here, we are not throwing and querying objects from the database. No, we are using an old-fashioned SQL language, and that's the way we do it. So you don't have to work with JPA all the time. You have other options, and if the requirements, if it's feasible for you, and if it makes sense, you have to think twice, and you can go into different directions. And then the final tip about the whole front end. We've talked about a little bit about the injection, the building up the business logic. We talked a little about the database. Now it's time for the front end. The problem with the front-end and web tier of JavaEE application is that in many organizations, and very often we are facing web development anti-pattern number one. We are letting backend engineers develop the front-end UI. If you've ever worked with a graphical designer, you know that these people are obsessed with one thing, with pixel perfectness. Now, these are guys that will see that your HTML is not reflecting the original design, because this particular rectangle is shifted by 12 pixels to the right or to the left, and they know how to do it better in the pure HTML or with a pure JavaScript. The problem is that on the JDD stack, we usually don't have pure HTML. We are using some JSF with facelets on it and some components, and the components are built on their own way with their own styling, and we are not exactly able to style it in the exact way the designer would like to do it. That's pretty much a fact. So there are multiple problems with JSPs and JSF. I personally try to avoid it. That's my approach. But there are people who are perfectly fine with it. This is still a tool for very particular use cases. And if the use case for JSF is your use case, you will be probably happy with that. The problem I always had with JSF was that it has a very steep learning curve, and I felt that it's working kind of against the whole idea of the web. You know, I have to admit it. Before I started doing Java, I was doing PHP, and in PHP, you know, whatever you wanted to do, it was very much related to the actual HTTP thing that it was running on the top of it. And then when I've seen JSF for the first time, yeah, it was running against the whole idea of the stateless web. So I have this problem with JSF, and it didn't allow me to get the very fine-grained control over HTML and so forth. So I started to look for ways to just kind of bypass it and do it differently. So yeah, we can have a few approaches. We can wait until JavaEE 8 and something called MVC. We could have waited for JavaEE 8 and something called MVC 1.0, so action-based MVC. Though it's no longer true, and as they've ditched it from JavaEE 8 and push it towards JavaEE 9. There is already a reference implementation of it, so that you can work with your application in a similar way you've been using it in, for example, Spring MVC. But it's not working everywhere yet. It's still early RC, I think, version. Then we can take a set of CDI extensions and try to use applications like struts, well, frameworks like struts2 on the top of our JavaEE application. That kind of works, but usually requires some hacking, and you cannot get away without some initial context lookups and so on, which makes your code a little bit dirty. Or you can wait again for next release of JSF, because the whole idea of JSF now is getting closer to the notion of being a default framework on JavaEE stack than being a generally web framework for any other application server. However, for me, none of those really worked, because in my situation, I have those designer people, I have those people fiddling with HTMLs, and what I wanted is I just wanted to give, you know, them their tools. So I wanted to leave the front end for the web developers, and they are stuck, you know. They are smart guys and they know how to do things. So what is the stack, the typical stack of the front-end developers? Yeah, we all know it. There's Node.js and NPM and Bower and some other fancy frameworks, and left but sometimes not working and sometimes working. We can make jokes of it. But they are doing their web thing nicely, and they can play with their toys. So they have these dependencies on Bower and some then dependencies on jQuery's backbone and so whatsoever. And we are having our own dependencies with the application server and all those components. And we start to wonder, is there any way to combine them and make them work together. Yes, there is. And there's Maven for the rescue. Nobody expected Spanish Inquisition. So within Maven, we have lots of plugins, and some of the plugins are very smart, are smart enough to, for example, run the local Nodejs or run the local npm to do the web thing for us. You can pretty much do the same with a single end plugin, but there are more dedicated plugins to them. The whole idea is that you can take the whole front-end application written in whatever JavaScript people are writing applications and put a single POM file, totally independent of the rest, that will trigger their builds, will put everything they've written into a very particular folder, which is a folder of your choice, for example, target/up. And then, with another Maven plugin, you can take this whole directory, for example, called app, and put it into a folder meta-inf resources. Why this meta-inf resources is very important? Because, like 6 years ago, when Server 3.0 was introduced, there was this whole idea that whatever you put into your meta-inf resources will be visible outside your jar file. So you can put the whole web application into a single jar file and make it a dependency of your project. The Server 3.0 injection, because that's how it's called, introduced a notion that whatever you put into your web-inf lib, and if it's a jar file and if it has a meta-inf resources file, then whatever it's within this file is ultimately exposed as a static resources on the web. And that's why we have this webjars.org website where you can download every single front-end library like jQuery, Backbone, AngularJS, whatsoever, as a jar file that you can put into your as a dependency into your Maven project. It looks pretty much like this, and this is a dependency that I've built, but you can put, for example, org.webjars jQuery in a particular version, and then jQuery will be available to your application, but not directly copied to code, but as an external dependency within Maven. And for me, these were 5 things that made my JavaEE experience far less depressing. So first, I had to learn, or acknowledge that there is JavaEE and it changes, and there are certain things that changes. It doesn't change very often, so it's easy for you to catch up. And things change for the better, and we have to know that before we start bitching around that it doesn't work. And then I acknowledge that, yes, the standard is a guidance, but I am stick to JBoss application server or WebLogic or WebSphere or whatsoever, and I have to accept it, and I don't have to work against it, but it's my friend. And then I have certain tools to limit the boilerplate, like the Apache Delta Spike, and certain libraries to do the persistence differently, like the Juke. And then I can work with my front-end team very effectively, with them doing their front-end in the way they would like to do it, and me doing the back-end stuff and the services in the way I would like to do it as well. So these are my 5 tips for the applications to be less depressing. Do you have any questions? If not, I'm still around here for the next 2 days, so you can approach me directly. You can catch me on email, and this whole talk and the examples that I've been talking about, the snippets of code are available on my GitHub account, so you can fiddle on your own and see how it's working, how the code is working. It's not a very huge project, but it just shows certain concepts over there. So thank you very much, and enjoy the rest of the conference.